Hello, everybody. My name is James Whatley. My talk today is called Building Apohaqui Station, an Adventure in Laser Cutting. Continuing from my presentation, Photo Interpretation for Model Makers, this seminar summarizes how I went from taking the raw field measurements of the Apohaqui, New Brunswick Canadian National Railway Station to the completed model that I built in 2022. Drawings were made using computer-aided drafting or CAD software, which enabled fabrication of many of the principal parts with a laser cutter. The laser cut parts were then supplemented with many traditional hand techniques in model making, including finishing using conventional brush and spray painting, as well as chalks. Even if you do not plan to try laser cutting, this presentation covers some useful tips and methods you may be able to apply in your own projects. Many measurements were taken on site in the summer of 2021 at the Agricultural Museum of New Brunswick, where the Apohaqui station now resides. Photos taken during a previous visit were marked up as the measurements were taken. This makes it a lot easier than having to stand there and make a lot of sketches on site if you are able to do this. The field notes were organized and used to create a drawing of the elevations and plan view. Computer-aided drafting software was used to produce files suitable for laser cutting. Other vector-based drawing packages are also useful. I chose to use the 2D CAD software DraftSite by Dassault Systèmes based on recommendations. Lots of alternatives are also available in this field. DraftSite is very compatible with AutoCAD at a fraction of the price. I'm using the standard basic version, and the annual license renewal fee is currently about $170 Canadian. However, new users are now being offered DraftSite Professional at about $300 US per year, or the advanced DraftSite Premium versions at about $600 US per year, which includes 3D. This is the DraftSite screen showing the main Apohaqui elevation drawing. So the control buttons are at the top and they're similar to other CAD buttons. And the command window is at the bottom left and is functionally similar to AutoCAD. Once you get used to it, using the command window allows the work to go much faster. Like all CAD programs, DraftSite includes standard features for manipulating drawings, such as the zoom command illustrated here. So you can see that I've zoomed in on the front door and I've zoomed in on the door handle. So you can really add a lot of detail quite easily. There's a really good help feature that's available in DraftSite by pressing F1, and it includes an excellent alphabetical command reference. For those familiar with AutoCAD, many commands have slightly different names but function the same. Once you memorize the relatively few commands you actually need, typing their shortcuts in the command window is faster than using the icons at the top. Additionally, hitting return is a convenient way to repeat the last command. Now, here are some example DraftSite commands. So using the line command, you can draw a rectangle in the usual way with 4 lines. The trim command is then used to get rid of the excess. So imagine drawing this with a pencil and paper using a conventional drafting method. You would basically take an erasing shield and bring it up to the corner and erase the excess line. And this is exactly what the trim command does. Now, after setting the drawing units, for example, actual inches or millimeters, whatever you want to work in, there is another way to draw a precisely sized rectangle using the rectangle command. And many commands have abbreviations, which in this case is RECT. So the start point is typically the lower left-hand corner, and it's specified with the cursor. And then you enter the width and the height. So here I have a box 50 inches high and 100 inches wide. So it's another way to do that. There's another extremely useful command for the type of work model makers use or perform called the offset command. And it's very useful for repeated parallel lines, for example, to represent building or car siding. So the amount of offset of a line or shape is selected, for example, 3.5 inches. The line to offset from is clicked on, and the side to offset to is clicked on. So you can go very, very quickly, boom, 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 and fill a whole side in with lines. There's other ways of doing this as well. And one of them is using the array command. It's very handy for drawing features like multi-pane windows or the repeated scribe siding lines, for example. You draw one pane of window, for example, in this case, which is an object, and you select it. And then you call up the array command and a menu pops up. And it asks you to fill in the number of horizontal and vertical elements and the spacing to be repeated horizontally and vertically. And then you hit OK. And in this case, I'm asking for a 3x3 array, 3 across and 3 down. And there you go. So you don't have to laboriously draw everything by hand. Now, once the overall drawing is completed, individual parts are extracted into separate drawing files for sending to the laser cutting machine. Shown here are multiple copies of the roof bracket that are grouped together so they can all be cut at the same time. One bracket was duplicated and turned 180 degrees using the copy and rotate commands. And then this pair of brackets was then arrayed 4 across and 5 down with the array command. So this is a very useful command that I find is often a real go-to command. Now, the individual window sash and trim components were drawn separately for laser cutting. And you can even create three-dimensional aspects. For instance, the window cornice and sill were created by drawing additional pieces that were glued together in layers during final assembly. As many similar pieces as possible are grouped together on one sheet. And by working in full-size dimensions, CAD files to be sent to the laser cutting machine can then be pre-scaled to any desired ratio, for example, 1:87 for HO. And this gives you a hint of how kit manufacturers can easily produce the same kit in different scales because they have one master file and then they create specific scale files for each kit they want to produce. So the machine takes whatever it receives and cuts the pieces to exactly that size. And the laser cutting machine software can accept various drawing formats such as DXF or PDF or other formats. Now, the example of the finished roof brackets cut by the machine are shown at the right, and you can see how they look like the original drawing. However, the laser beam burns off a bit of the edge of the material as it cuts each part, which is equivalent to the kerf of a conventional saw blade. For miniature parts, a trial and error testing process is used to establish how much of a small allowance needs to be added or subtracted around each drawing feature to compensate for laser kerf. Programs such as Lightburn can now use this allowance to do the compensation automatically. Some older programs lack this capability, which is something to watch out for. In this case, the margin turned out to be about 5.5 thousandths of an actual inch, which is about 1/2 inch in HO scale. Although small, this allowance can make quite a difference in the fit of very small parts. However, this is less critical for larger features such as the entire wall width. Now, for this project, materials used were basswood sheet, paper for the roof shingles and wall shingles, and a material known in cabinet making as backer board, which is also referred to as laser board in the hobby field. Backer board is the resin-impregnated paper material laminated to the insides of kitchen cabinets to limit any tendency for the finished wood veneer on the front that cause warping. Backer board is an interesting, very tough material compared to styrene and wood. It comes in several thicknesses, and parts cut with the laser have very crisp, precise edges, making this an ideal choice for windows and doors. A little bit of sturdiness doesn't hurt. And you can see on the right all the major parts laid out that were cut with the laser. And you can see how all the windows were grouped on one fret and cut at the same time. Now for assembly, the laser cut subwalls were removed from their frets and labeled as to where they go. Separate pieces of northeastern 1/32 scribed and plain basswood sheet and a strip of 2x4 to represent chair rail were individually cut and fitted for the interior wainscoting, chair rail, and drywall panels, forming a laminated sandwich. Now, the reason I did this is I simply forgot about the wainscoting when I did the original CAD files, and I thought it would just be easy enough to cut these parts to fit. The door and window openings were trimmed to match the laser cut subwalls and then sanded with homemade sanding sticks cut to the necessary width to keep the sanded edges straight. Now, if you use a narrower file or sanding stick, there's a tendency to put a crown in the surface. So it's very helpful to have the sanding device match the width of the opening. Just a simple tip. The wall corners were mitered at 45 degrees using a jig from a 2x6 that I cut on my table saw, and using a double-sided sanding block made from a piece of hardwood with 2 different grits of sandpaper on it. Pencil guidelines on the jig help keep the workpiece square, and the 90-degree edge of the 2x6, both edges were also accurately cut and are useful for trimming and squaring other sheets to size. So you can see I have the jig resting on my knee, and basically I'm going to take the sanding block and slide it back and forth on the edge of the bevel while holding the wall panel at one of the 90-degree lines. It's actually easier to do than to describe. Before final assembly of the wall panels, the laser cut door and window frames for the interior were added after carefully separating them from their frets and pre-painting everything to ensure neatness. Additional trim was made from pre-painted stripwood. 45-degree lines drawn on a hardwood block help set the miter angles for the trim. The floor and all interior wall panels were also pre-stained and/or painted prior to assembly. V-blocks and small machinist squares were used to ensure everything was plumb. A 1-2-3 block is another useful thing to add to your toolkit. The green cutting mat in the picture is resting on a sheet of plate glass that I have built into my workbench top. So that's a plenty flat surface for what we need. The roof base was carefully fitted to allow the finished roof to be removable. And if you look carefully in the center of the upper picture, there's some homemade leaf springs made from phosphor bronze sheet that made up with a pair of phosphor bronze wire running up the interior wall to feed the LED lighting. This is a very neat way to avoid having wires hanging around inside a model that you're taking the trouble to put a finished interior in. The roof subpanels were framed and the LEDs were wired and tested. A circuit board for the series resistors is in the middle where that jumble of wires is. The roof panels were added next, and another jig was used to establish the 5-degree angle for the roof flare. Wax paper ensured the removable roof didn't become attached to the walls during gluing. Commercial lamp fixtures were too large, so I turned the 8 required on a mini lathe. Pre-wired 0204 warm white surface mount or SMD LEDs were installed. The pictures show a test fitting before the shades were painted. Pre-stained stripwood clapboards and laser-cut paper cedar shakes were applied to the exterior walls. The stain used was thinned original Floquel unobtainium boxcar red. Most recently, AK Interactive has a product called Real Colors, which I believe would be suitable for the same purpose. Acrylic paints may cause warping on wood and paper and are not recommended for this application. And also, priming is not a good option here, as the stain will not absorb naturally and produce the desired variations. Pre-painted laser-cut exterior window and door frames were installed next. And as a matter of interest, Humbrol Enamel Matte 103 Cream is a good match for the CNR trim color. There's an ivory in the AK Interactive Real Colors line that's also pretty good for this. A drilling jig for the roof brackets made the installation of the reinforcement and locating pins repeatable and consistent. So at the top, you can see I made a simple jig out of styrene, and there's a couple of holes in the side, and I put each roof bracket in and drill a couple of little holes and put a couple of pins in, hold them with super glue, and that makes a very secure attachment to the walls. And a second jig permitted the mounting holes to be accurately located at the correct position down from the roof. Asphalt shingles were represented using strips of paper sprayed at a distance with two grayish shades of matte Humbrol enamel to create an incomplete and slightly rough texture. These were cut and slit using the method described by Gib Kennedy or Jack Work in their model railroader articles from the late 50s or early 60s. Now, I actually laser cut these now, and I found gray cardstock for this type of asphalt shingle, which works very, very well. And in this case, I applied the shingles using ambroid cement or GS hypo cement for watch crystals to prevent warping the roof. I've more recently been doing this using a 3M double-sided photo mounting tape, which appears to be another good way to do this. The chimney was also laser cut from my drawings in two passes, one that cut halfway through to create the bricks and the other to cut all the way through to separate the parts. Software such as Lightburn allows etching and cutting to be specified in one process, thus avoiding the need for two separate drawings. Chimney flashing was cut from kitchen foil, and you can see how it's carefully folded into the bottom perimeter of the chimney. And initial weathering was then applied to the roof with an airbrush angled upwards to catch the cut edges of the shingles. And I've effectively reduced or eliminated this step by using shingle material that's the base color that you want to end up with. Windows were cut from microscope slide cover glass using a diamond tip scriber. This is something that's similar to scoring and snapping styrene, except you need an extremely light touch to cut the glass. And in fact, not much more weight on the scriber than the weight of the scriber itself, but it actually goes quite well. And these pieces were glued in place with minute amounts of GS hypo cement after I cleaned the windows with lint-free tissue. Now for the interior details. Bathroom fixtures were carved and sanded from small pieces of basswood and are based on typical dimensions. The sink taps and spouts are bits of wire soldered together. The safe, scale, and other pieces were made similarly. The garbage cans are brass tubing. The broom and dustpan are bits of styrene and brass. The ticket case was made from individual pieces of stripwood with tiny bits of colored paper to represent tickets and baggage tags. Luggage pieces are blocks of wood carved and standed to typical dimensions. And I'm sure the 3D printing folks out there are saying, get with it. And I probably will, I hope someday. Interior details. The waiting room benches and the operator's desk are basswood stained with flow stain. This was a really, really excellent product, which is sadly no longer available. So perhaps a commercial wood stain might work. Items on the operator's desk are bits of wood, paper, and wire. The telephone accordion mount was cut from etched wire mesh. Its transmitter and receiver were turned on a lathe. The typewriter is a photograph glued to carved wood. Its green felt cushion is cardstock stained with a marker pen. Now, making signs like train bulletins are another example of the usefulness of a CAD program like DraftSight. In 1954, the citizens of Apohaqui still enjoyed decent train service. This was taken straight out of a schedule for 1954. Station name signs are also easy to make in CAD or other software. DraftSight includes many text fonts, and Arial was the closest one I found to match CNR practice. The advantage of CAD is the ease of directly setting the lettering font size to the 8-inch size required in this case as per the prototype. So that's really what you're gaining as opposed to using Word or some other program. Very precise in the drafting program. Making artwork like vintage travel posters from the internet, in importing them into CAD and rescaling, which basically means stretching or shrinking them to fit an appropriate size rectangle. For example, 20 by 30 inches is a fairly straightforward way of obtaining miniature signs or posters or artwork. Now, some artwork you may come across, if originally scanned full size, may already import correctly into the CAD model space if the CAD drawing environment is already set to full size, for example, 1:1. And then the desired scale factor, for example, 1:87 for HO, is entered at the time of printing. Photographic files, for example, in the JPEG format, can also be imported into CAD and rescaled using the same method. This is a picture I took of a painting in our living room. So I just used its actual dimensions to directly rescale it in CAD. By the way, some model makers use similar methods to make decals. Artwork is imported into one layer of a CAD or graphics program, and the decal artwork is drawn over top in another layer. The station clock is also an image from the internet, rescaled, printed, and glued to a scrap of 1/32 wood sheet to give it some depth. The strip wood was trimmed to the clock outline, and the edges were painted to match the clock finish. So finally, here's the completed model. And it was a fairly big project, but I really enjoyed being able to recapture this station, which probably dates from the 1930s. And I added, as you can see, other details on the roof. There's the weather head for the electrical service and stains coming off the lead soil stack and chimney and so on. And you can see in the front corner there some of the light fixtures I added. And you can see the cornice above the exterior windows, which, as I mentioned earlier, was made by cutting about 3 pieces of trim in successive sizes. And here's the interior. You can see the washrooms and waiting room, all the items in the operator's office. And down back, you can see the electrical meter and broom and dustpan. There's another view of the interior. And a close-up of the washrooms. And you'll notice that the station people have kindly provided toilet paper and a paper towel dispenser. And there's some luggage. The luggage has actual baggage tags lettered for destinations in Moncton, New Brunswick. And the scale has a package on it with also an address on it. So there we are. So to conclude, preparing the drawings for laser cutting does take time, but the crispness and accuracy of the resulting parts, especially window sashes and roof brackets, makes this all worthwhile. A huge advantage of CAD is the ability to cut and paste repeated features and make use of these features in other models. Many commercial windows and doors are available, but some railway architectural styles are unique, including those of the CNR in this case. Learning a suitable CAD program is straightforward with dedicated effort. Excellent tutorials and general help are usually available online for many programs. DraftSight is a very capable and relatively economical choice. Laser cutting doesn't eliminate the need for many conventional model making techniques, as you can see. However, tasks like laying out a multi-pitch roof for a model by hand and getting the parts to fit is tricky, and the CAD work made this a much more accurate exercise. Including interior details on a foreground model adds a fun and imaginative dimension, and each piece can be considered to be a mini project on its own. So just go out and get started. I would like to thank my wife for helping me take field measurements of the Apohaqui station during 2 site visits we made in 2021. I would also like to thank my sister-in-law, Jeanette, for her tutoring in DraftSight and assistance with the initial program setup. I would also like to thank Alan Welch for making his laser cutting machine available for this project. So thank you for watching. As Porky Pig would say, that's all, folks.